Hi, this is Russ Andersson, and I'd like to talk about field of view and focal length and plate width today. Now, SynthEyes, a match moving software, uses a field of view. That's what it calculates internally. But people can read focal length values off of the lenses of their cameras. And that focal length value isn't really usable unless you also know the plate width, which is the size of the actual imaging portion of the sensor chip in the camera. And that number is really hard to get a hold of exactly. So what I'm going to show is a way that you can figure that out, and also kind of what's up with these whole field of view, focal length, and plate width values. How can you convert back and forth between them to get something useful? So let's just start out showing what goes on. Suppose SynthEyes has some fields of view values, and it's gone through and handled a zoom shot that happens to come out with this particular bunch of field of view values. And we know what the plate width is. We're shooting on 35 millimeter film, say, that has a 36, this is a still camera with a 36 millimeter wide imaging area. So that's just a standard value. So SynthEyes could go and on the lens panel could display the focal length for you, and it uses the following calculation to do that. It's going to be half the plate width divided by the tangent of half the field of view divided by 57.296 to convert to degrees. So here's a little trig that you didn't know you were going to have today. But you can just punch it into the Google spreadsheets and let it do the work for you. So it's going to give you here the bunch of different focal length values with a 10-degree field of view. Of course, that's really a long lens, and vice versa at the other end of the spectrum. Now, if I go and change the plate width here, all of a sudden, this value for the focal length starts to change. And so if my plate width value isn't right, the focal length value over here is going to be meaningless. And that's what happens a lot of times when people just start playing around with focal lengths without having set this plate width up exactly. Now, if you have gone out on a set and recorded some values for the focal length and you want to feed them into SynthEyes, it's going to go and do exactly the reverse of this calculation. So let's suppose instead we recorded these different focal lengths, and we're going to have SynthEyes calculate the field of view. So what it's going to go and do is calculate twice the arctangent of half the plate width divided by this focal length. And then we need to convert back to degrees again. And now we have back a nice little set of field of view values. So that's what it's doing internally when you want to give it some field of views. Now, here comes the fun part. Suppose what we want to do is give it both, we figured out both the focal length and the field of view. And this is something you can do from a set of test shots. You can go out and shoot a bunch of shots, record what the focal length is for each shot, then go and track it in SynthEyes, have SynthEyes figure out what the field of view is, and that's going to let us compute exactly what the back plate width is. So I'm going to show how to do that, and that's kind of the useful takeaway from this whole thing. One note, a lot of camcorders these days will just show what the range of the lens is. So maybe it goes from 8 millimeters to 50 millimeters or whatever for a small image sensor size. If you just use those two values, you're going to have a really tough time getting anything useful, because at the one end, you've got a very low perspective shot, shooting from far away telephoto. At the other end, you've got this wide angle with a lot of distortion. So you're not apt to get to good results just from using those two values. And part of the lesson there is, if those are the only two values you can read off the lens, it's really not worth a whole lot of trouble anyway. Suppose we've gone and measured a bunch of values for the focal length for each of these shots. And I'm just giving it kind of a rough approximation of each of the corresponding values here. So as if we had gone out and done the experiment I proposed. And now we have a set of focal lengths and field of views. So we're going to feed in the formula now to compute what that back plate width is. So it's twice our focal length times the tangent of half the field of view divided by 57.296. I'll just show that. And now we can extend that out. Now you see that we have a bunch of different plate width values that are all kind of around the original value, but they're a little different because you saw that their field of view value wasn't exact. So if you go out and you do this experiment, you're going to see something like this, where you get a bunch of different values that are all going to be sitting around the same value. So, if we wanted, we could go and let's see if I can get this to do the right thing. Just average these things out. And so we get an average 35.3 millimeters or so. So, that would be a reasonable approach. Like I said, the distortion especially is going to be a problem at the one end of the spectrum here. And you're going to probably see that back plate values change around a little bit in response to that. So I hope this gives you a way to take a look at the back plate values if you like. I haven't run this experiment here yet. Perhaps that'll be a future episode. Just one final note, I didn't change the column heading here correctly. This should be the plate width.